Alright, hello everybody. We have another video here today, and today we are doing the, I believe, the 2021 paper for the MAT. So, I've not really looked at this paper much, but I'm going to be attempting it. So do take my answers with a pinch of salt, always check them. Don't take it for, correct. But here's question A. You've got a regular dodecagon is a 12-sided polygon with all sides the same length and all internal angles equal. If I construct a regular dodecagon by connecting 12 equally spaced points on a circle of radius 1, then the area of this polygon is your answer. So I'm thinking we start this off by drawing that circle of radius 1. So I'll do that right here, and we'll just say this is of radius 1. So if I draw this, okay, so that's our radius 1 circle. And this dodecagon, we'll just draw a couple of points. So you got that one, and then you got that one, that one, that one. So it'll be like 4 points in each section, each like sort of quarter arc. Yeah, and then this would be your dodecagon. That should be correct. Well, about correct. Doesn't matter much. We just need to find one piece, I think. So look, if we do this here, we get that. We'll find the area of this sort of triangle or arc. Yeah, so they each have the same angle inside there. So that angle is going to be the same if I do this for each point. So we have 360 degrees in a circle. There's 12 sides to this, so 360 over 12 equals 30 degrees. So that right there is 30 degrees. And then obviously this is radius 1. So that's 1, 1. Now we just find the area of this sector here, which is a half r squared theta. Obviously we'll get that into pi. It's a bit easier. So, well, you can do half AB sine C, can't you? I think. Well, we'll just do it the radian way. So you have a half times 1 squared times, let's see, 30. We're going to convert it to radians, so 30 times pi over 180. And that should be the area of that single sector there. So 30 over 180 gives you 1 over, is it 6? Yeah, 1 over 6. So this is a half times 1 times pi over 6 is equal to pi over 12. So that's one of these sectors. So how many of these do we have? Well, you've got one there, and there's going to be like another there, and another there. So there's 3 in each sector, 3 in each quarter of the circle. Obviously 4 quarters. So you're going to have 6, 9, 12. Yeah, it's just 12. So we're going to have 12 times pi over 12 is equal to pi. Well, that's just gave me the that's just gave me pi, hasn't it? Alright then. Well, in the area of this polygon, are any of them close to pi? 3 times root 2? No. 2 times root 2? No. Just looking at the answers here. Well, if you think about it, it's not really an arc, is it? This is obviously the circle, but you're going to have it's going to be a sharp line there, so it is a triangle. So if we do half AB sine C, then you're going to have a half times 1 times 1 times sine 30. So yeah, I think that should be correct then. A half times sine 30 is the area of one of these little sectors here. So sine 30, we do a little hand thing, you get root 1 over 2, isn't it? So 30 degrees, root 1 over 2. So you have a half times a half, which is a quarter. And then we just times that by 12. A quarter times 12 is equal to 3. So I think the answer's D, well not D, E, which is, if we look at our little thing over here, it is 3. So pretty sure that's our answer there. Alright, and now on to the next one. We have, I'll use another page for this because it's going to be quite a hefty one. It's got an integration symbol, so it is the positive number A satisfies that equals 5 if A is a certain value. Okay, so I'll write this down at the top here and we'll work from there. So you're going to have the integral of A, convert that to fraction, well, indice form. Okay, so now, yeah, positive number A satisfies. So I'm just going to integrate this and see what we get. So we're going to get x to the 3 over 2, multiplied by 2 over 3, because it's obviously a 1 before that. You raise the power by 1. You divide 1 by 3 over 2, you get 2 over 3, plus x cubed over 3. And then there's a and 0. Okay. And that's equal to 5. So 2a to the 3 over 2 over 3 plus a cubed over 3 equals 5. Surely shouldn't be this simple. Okay. 2a to the 3 over 2. I'm feeling this is lowering me into a false sense of security and I shouldn't be getting this. Okay, and we're going to factor out a to the 3 over 2. Equals 15. So, positive number A alright then. So where does a to the 3 over 2 equal 15?
No, leave him. Get your seat.
Well no, because well, we could just plug in values because it's given us a list of values to pick from. So if I put root 3 into there, you're going to get root 3 cubed, which is root 3. No, root 3 cubed is 9 root 3, and you square root that, you get 3 times root 3. Let me see, if I make a root 3, so you're going to have root 3 cubed, and you square root that. So that's going to be the square root of 9 root 3. Which is, I believe, just 3 root 3. Okay, so you're going to have 3 root 3 times 2 plus 3 root 3 equals 15. So you get 6 root 3 plus 9 times 3, which is plus 27. So it's not that. That doesn't equal 15. So it's not C. Oh well, it's not B actually. Now if we look at our next one, we have C, which is a to the 3. A equals 3 to the power of 2 over 3. So you have, if we do that, you have 3 to the 2 over 3 to the 3 over 2, which is that cubed and then square rooted. So that cubed is going to be 3 squared. You square root that, you get 3. Okay. And now we are going to have, let's see, 3 times 2 plus 3 equals 15. Which that's 3 times 5, which I think that is 15. So I'd say the answer is C. Alright. Okay.
Take on C.
Now, if I just turn the page here, just get to a fresh page, we have our next question, which is C. So, C is tangents to y equals e to the x are drawn at P, EP, and Q, EQ, or e to the power of Q. These tangents cross the x-axis at A and B respectively. It follows that for all P and Q, and then you have a list. Okay, let's see, what should we do here then? These tangents cross the x-axis at A and B respectively. We should probably draw this. So where's my ruler? I'm not going to use a pencil, although you should. But I'll just draw a little diagram here. Okay, y equals e to the x. That's just your standard, isn't it? Your standard, or what is it now? Exponential graph. Which, to my knowledge, it goes like this. You know, it goes up and off. Okay, getting exponentially bigger. And now, if we have tangents to y equals e to the x, we're going to have tangents to this. These tangents cross the x-axis, so we're just going to draw 2 tangents. We'll draw one like that. That can be, tangents are drawn at P, e to the P. So let's say, I don't know, P is 1, Q is 2. We'll just do that. So P and then e to the 1. So that's 1. Well, this one can be Q. So Q is 2 and then e squared is like what? It's like 5 point something. 5.5 or 5.4. So Q is going to be, well, it's Q e to the Q, and then we'll have like P e to the P somewhere down here. Alright, so that's P e to the P there. So just like do 1, 2.7, and that one's, ignore that it's crossed out, but 2, like 5.4. Obviously these aren't the actual values, just giving them values relative to each other, just to map them. These tangents cross the x-axis at A and B respectively, so that's A, that's B. It follows that for all P and Q. Okay. So let's look at what our things say here. We've got PA equals QB. So from this, say that's 1, that's 0. So 0 equals QB, which would be 2 times 1. So 2. Let's say P was 2, that was 3. And then A was like whatever. Well, let's see where... Well, let's try and find A and B. So x equals 0. Y equals... Well, that's the y-intercept. We need y equals 0. So e to the x equals 0. Ooh, you can't have that, can you? Alright then. Well, P plus Q equals A plus B is one of the answers. So let's look at that. So that's 1, that's 2. 3 equals 0 plus 1. No, I don't think it'll be that. P minus A is greater than Q minus B. So 1 minus 0 is greater than 2 minus 1. So 1 greater than 1? I don't think so. P minus A equals Q minus B. So that's 1 equals 1. Could be that one. And then P minus A is less than Q minus B. No, because we found that we're both 1 in this circumstance. Then PA equals QB. No, because that's 1 times 0. 2 times 1. So I think the answer is going to be C. Obviously this is all just based on giving P and Q values, which they aren't. Those aren't their actual values. But it's just a way that I'm modelling it, so I think it could be C. And then the next one is the area of the region bounded by the curve y equals e to the x. The curve y equals 1 minus e to the x, and the y-axis equals. Note that ln x is alternative notation for log base e of x. Well, we'll try and do this one, but it may end up a little complex. Alright. Obviously, first off, I'm going to draw this, as you should when integrating and finding areas and such. You have to know if it goes beneath the curve. Oop, that's a bit wonky. Alright, 1, 2, 3, 4, 1, 2, 3, 4. That'll do. Okay, so we've got y equals e to the x again. Not my favourite graph, I'm not going to lie. That'll do for that. And then y equals 1 minus e to the x, which that's the same as y equals minus e to the x plus 1, which is like, that's y equals minus f of x plus 1. So that's going to be a reflection in the x-axis. Reflection in the x-axis raised up 1. So we're going to reflect this in the x-axis and then go up 1. Okay. Yeah, it's going to be something like that, isn't it? Well, no, It was a reflection of the x-axis. What am I doing? It just... Right, so it goes down there, and you add up one. Oh yeah. It's the right shape, the proportions are off. So it wouldn't be that far up, but it's the right shape, and that's all that really matters. Okay, and then the y-axis, so this here. So the area of the region bounded by the curve, this curve, and this curve, and the y-axis. So we need... Oh, give me a sec. Cat and dog bursting in. Anyway, right, let's look at this then. So we've got the area we need is this here, so we'll just mark that F. So what we're going to find is we need where these intersect. So you have e to the x equals 1 minus e to the x. So 2e to the x equals 1. E to the x equals a half. So then we do the natural logarithm of both sides of this, you get. You're just going to get x, because obviously natural logarithm cancels with e, equals the natural log of a half. Move that up. Okay, so that's where they intersect. And we need the area of the region bounded by the curve. By the curves and the y-axis. So, yeah, labelling this, you've got that ln a half, right? But where else would they intersect? Because they're surely going to intersect elsewhere, aren't they? Well, not necessarily, would they? Well, where else could they intersect? Could x be negative? Is it a case of x equals plus minus ln a half? I don't think so. Right, I'm just going to assume they want us to find it between x is 0 and x equals ln a half then. So that's what we'll do. We're going to integrate between them for both of these. And see if that's any of the answers on here. So doing that, you're going to get, you raise the power of x by 1, so that's what, e to the x squared, ln a half, 0 plus 1x, so x, and then we got to divide by the power. So that over 2. I think so. Alright. Minus e to the x squared over 2. It's ln a half, 0. So now we just put those values in. You're going to get e to the ln a half squared over 2 plus... Oh wait, no, we need to do a minus, don't we? So if we've got this area here, the area under this curve, subtract that area. So it's going to be negative of that plus ln a half minus e to the ln a half squared over 2. Okay, and now that's going to be equal to ln a half squared. You add them together, don't you? So if we add ln a half times ln a half yeah, you'll add those, so you just get ln1. Alright, so now let's see, you have e to the ln of 1 over 2 minus that plus ln a half minus e to the ln 1 over 2. So then we've got e to the ln, it's going to cancel, isn't it? You just get 1 over 2. So you have minus a half plus ln a half minus a half. So then that's ln a half minus 1, right? Let's see, is that any of the answers on here? We have 1 minus ln a half. 1 minus ln 2. And a half minus a half ln 2. ln 2 minus 1. Well, I think then what I'm going to do is I'm going to say the area is basically just this, but I got something similar, so I'm just going to say 1 minus ln a half. Maybe I just got the minus symbols mixed up somewhere in there. So that's one of the answers, and it's E. Although it may make more sense to say it's ln 2 minus 1. Yeah. I reckon it would be ln 2 minus 1. More likely. So I'll say D. Now, that's my attempt at this, and I hope that, you may have found this useful watching me do it, and you hopefully doing it alongside me. If not, I wish you to attempt this and to do the other questions, because there's more after this. It goes E, F, G, H, I, J, and then the big question 2. So there's a few more after this, which I reckon you guys will be able to do. I don't know if I got any of these right at all. I'm going to check afterwards. But yeah, I hope this was helpful in some way, or interesting, or whatever. But that was my attempt at the first 4 questions of the November 2021 MAT paper. And I hope you enjoyed. If you did, show a little support. I'll make more videos like this. Leave a comment saying you want more. Or give me a recommendation for another type of video, because I've got plenty I can do. But thank you for watching, and I wish you